So, good afternoon, everybody.
Good afternoon.
Good afternoon.
In continuation with yesterday's session, we are now on day 2 and we will start with the lecture 4. Before that, I would like to make an announcement that the course completion certificate will be issued to the participants who have attended all the lecture sessions and has paid the course participation fee. Along with the certificate, we will also send the video program of this short course in digital form as study material. One more request to the participants, they must type their name, contact number and email ID in the message box to confirm their presence so that we can issue the certificate to them based on the details given. Thank you very much. We will now go to straight away to lecture 4 and the topic is welding aspects in project and quality, and second one is use of artificial intelligence in welding technology. The speakers are Dr. Pankaj Biswas from IIT Guwahati and Mr. Abhishek Mukherjee is from IIT Kharagpur. Mr. Dr. Biswas, please take.
Okay. Thank you so much, sir, for giving me this opportunity to deliver a talk in the field of welding with aspects and quality requirement in project management and all. Actually, frankly speaking, I am not from this project management oriented specialization. Then also in my level based, actually, I'll try to deliver something which is actually what I feel required in actual project management. So I am sharing my slide now. After that I will start my talk actually. Sir, is it visible?
Yes.
Okay,
Yes.
fine.
Yes.
Thank you.
Maybe you can go for the full screen.
Yes, sir, I am going to.
Yeah.
So today I am going to deliver a talk in the title Welding Aspects in Project Management and Quality. Here I'll just discuss about some basic fundamental which are related to welding aspects in project and quality. So this is the topics you can see here. So many points I have pointed out. You can see here because here I will discuss about different things which are related to welding as well as it's important in the field of projects. Like first of all, I'll discuss about what is actually welding. That's which you are very well familiar. Then also I should start from that. After that, I'll discuss what is the means welding management, how the welding is managed in industry. Then I'll discuss about what should be the proper welding process for a particular types of welding project. Then after that, I'll discuss about some basic fundamentals which are related to welding, because without that discussion, you will not be able to understand the next topics. That's why I'll discuss about those points. After that, I'll discuss about welding quality and how the quality is affected by using different defect. So welding induce defect oriented things also I'll discuss. Apart from this thing, I'll discuss about once there is a defect, how we can inspect that defect. So welding related testing as well as inspection also I'll try to cover in this lecture, as well as once there is a terms welding where there is a lot of safety hazard. So how we can minimize this safety hazard or welding safety related management issue, that related things also I will discuss in these topics. And finally, I'll discuss about the quality assurance code and standard which we generally used to follow in different welding oriented project. And finally, I'll give you a briefing about how to estimate the cost for a welding projects. Okay. So first of all, you know very well that welding in general a process of joining two material plates and makes an integrated one where inter-welding structural integrity exists. So this material which we used to join, this material can be a metal or and their alloys, or this material can be some plastic also, that you are very well familiar. Generally, which types of plastic we can weld? That is generally called as thermoplastic. That means which is means recyclable. That types of material also we can what you call weld. Now you can imagine, just little bit I am going to tell about the story type, history types of things of welding. You can imagine before First World War, this welding was not used, because what happens, welding is such a techniques, intentionally we are creating a defect inside the, hello sir, am I audible? Hello?
Yeah, you are
Yes, yes.
audible.
Okay,
I
someone,
just request others to please switch off your mic.
okay, fine sir.
No, you
Yeah,
keep
you
on.
are fine.
You
Okay,
are fine, but others, I request others to switch off.
okay,
Otherwise, it's
thank you sir.
disturbing the speaker.
Okay. Okay, thank you so much, sir. So, little bit history types of things I am going to discuss about welding. You can imagine that welding is such a process where generally, in case of fusion welding related things, I am just telling. Once you hit the weld, here generally we to join this structure, or you can say plate, we generally melt that to parent materials. So once we melt that things, you can imagine there are so many different types of changes occur. So what we can say, that means by welding intentionally we are creating some defect. So what happens then, also we can't avoid this technology nowadays. Why? Because due to this heating, melting, these types of issue, there are coming different types of heating, melting related defect like porosity, blowhole, crack, so many things are there. You can't imagine. That's why you can say that before First World War in 1914, this welding was not generally entertained in industry due to crack issue. Because what happens, once you do the welding, due to this welding there are coming different types of defects. From that defects, generally what happens, there are coming some crack and other things, which generally what happens, destroy the structure, that you can say, or they destroy the service life of the structure. That's why it was not used. But use not used means very drastically, that I am telling. But generally to promote this welding process, generally in 1919, you can say, a person whose name is actual whose name is A. Davy, that you can say, who is a American, who generally established American Welding Society in 1990. You know that to promote some technology, everywhere there is a hand of American. So like this American society established in 1919. So from that onwards, actually, you can't imagine, generally welding gain its acceptance in the field of manufacturing, because you see, welding has lot of advantage compared to other joining technique, as well as it has some drawback. You see, compared to other types of manufacturing process, generally once you compare, there are some pros and cons over each another, that you can say. But in welding also same things are there. But once we compare with some other technologies like casting, or some what it's called forging types of technology, where generally, or riveting types of technology, by which also we can join the structure together to make an integrated one. But once we compare those things with welding, it has observed that welding has some very high number of benefit compared to those technology. So in welding, though there are so many defects, but nowadays you can't imagine, it's welding generally is using in industry such a way, almost 40% expenditure we spend in the field of welding technology. That's why you can say welding is now gaining actually lot of importance in the field of what it's called project management, quality control, and all the things. So now I am going to this that things here I have written. You can see that after First World War, that means after establishing of American Welding Society in 1931 onwards, the growth of this welding technology is generally faster than the general industrial growth. So nowadays we have almost 35 to 40 different categories of welding process are there. Now you can think that way why these different types of welding process are required. You see, because every welding process have same purpose. That means here we are melting the plate and we are joining these two plate together. So then you can think, sir, why this is why there are so many different types of welding technologies coming. But there is the things actually, you see, where there is a need, there is coming some research from there, some new things is coming, that new thing generally will be applied some new application, that you can say. So based on that thing, generally some new things we are incorporating in a particular existing setup, and we are giving some other name, that you can say. But you can say the basis of all welding technology generally same. You can say there we are using some torch heating or using some heat to join two workpiece together and makes a integrated one. That is the basic thing. But then also I have written here, you can see here generally we can use nowadays there are 35 to 40 different categories of welding process are there. Now, before going to discuss about the welding management and all the things, how this welding technology are grouped and where this welding technology are applicable, if you will not decide this welding technology in proper welding project, then your things, your project quality, your project outcome will not be appropriate. So first of all, I will discuss about that things briefly. After that, I will discuss rest of the things successively. So well management in industry, little bit I have written. So how to manage a generally welding related what it's called projects in industry, or you can say how we manage this welding. So you see, to achieve the goal of a welding project, generally the following points need to be considered. So because for proper completion of a welding process, or you can say for proper completion of any project, that you can say, we should consider that the completion of the project should be in allocated time, and we should that means expense the what it's called expenditure, whatever the things required, that should be within the budget, and we should maintain the quality standard. Little bit I have written here. Now welding management nowadays gaining attention globally, because you see nowadays this welding technology have a demand in outsourcing as well as in boosting of this welding related manufacturing in abroad also. So if there is a lack of these managements are there, then what happens? Your welding project limits the innovativeness as well as competitiveness among the other industry. That's why proper management of welding related project is essential. How it is, that I will just discuss in today's lecture. So first of all, I will discuss the what are the different aspects required to complete a welding oriented project very successively. That fundamental thing first I will discuss. After that, I will discuss little bit about this management oriented thing. So you see, so for management of a welding project, these are the following aspects need to be considered. So here I am not going to discuss about the details, or I'll just of these different points which I have included here, because if I'll go to discuss about the details of each and every point, then it will take itself 3-4 lecture. What I'm telling, and so I am just giving you the briefing, so you can gather idea in this field, so that you can manage a welding related project very successfully. So that aspects here I am showing. Here you can see, to manage welding process, first and foremost things, there should be a proper planning of following points. Here I have written, you can see. So in planning generally, if you have proper planning of the following different points I have written, then what happens, your welding management will be proper. There are some other aspects like in quality controls, this following point you should be considered during your welding oriented project management. So many points are there, you can read these things, so I am not going the details about this thing. As well as in communication, you should consider the communication aspect in welding management. You should consider the resource management, you should consider the risk management, and finally you should consider the project monitoring and control. These are the following aspects which are required generally in welding management. So you just go through these different points, you will get the detailed idea from different types of management book, welding oriented management books are there, you will get the idea. So just I am showing here what are the different aspects generally required in welding management. Now, about these different points, some of the very important points which I will discuss in today's lecture. Like first of all, I'll discuss what should be the proper welding process for a particular welding oriented projects. So you can imagine what I have already told you. Generally, welding is a highly essential tool nowadays and a crucial aspects of many industrial projects. In which types of industry this welding project is very much important? The industry which are related to manufacturing, construction, and industrial or engineering industry oriented industry, that you can say. Why this welding is a very crucial or you can say aspects or essential tool? Because generally welding is such a process by which you can fabricate a very complicated shape, a very complex shape you can fabricate. Then you can use the welding process in different types of what it's called material. That means welding you can use a versatility. That means its application in so versatile. That means you can use this welding technology in different what it's called material. So due to this, generally this welding is a very important tool. Okay, this welding not only using for joining what it's called purpose, for it is also using for repairing and maintenance purpose also, as well as welding is also used for large metallic structural purpose, and it has also has well quality, as well as it is also a reliable types of technology, that you can say. So here I have written a very important point. Now you see due to these following aspects as welding have, that's why what happens, welding is gaining very much popularity in the field of manufacturing, that you can say. Now, to select a proper welding process is a very much important thing. So before going to start a project, what types of welding processes is required to complete that project, that you should know. That's why here I am just discussing what are the different types of welding process are there, and what are the what are those welding process for different types of application. Little bit briefly I will discuss those things. That's why I have written the selection of proper welding process has huge impact on quality and cost of the product. Because for a particular project, if your welding process means choosing of your welding process will not be appropriate, then what happens, your product quality as well as cost will be drastic change. There will be drastic change of quality as well as cost. So that's why I have written here, you can see the right decision regarding the process and equipment selection can result in a great reward, including remaining competitive in the global market. That's why before going to start a project, first and foremost thing required is what types of welding process you should choose, and what types of welding procedure you should do there, so that you can get a what is called required product and required quality of that product. So here I am showing, that's why first of all I'll discuss about little bit what are the different types of welding process are there, and what types of welding process are used for what types of purpose. So you see, welding has different categories. I have already told you over 40 different categories of welding process are there. These welding process are grouped depending upon how generally this heat is coming, whether in some welding process pressure is required or not. That's why here I have shown that this welding is classified depending on its source of heat. It is generally categorized depending upon its pressure. It is categorized depending upon its phases of base and filler material, that you know very well. Phases means whether it is solid state, liquid state, or what a solid liquid state. So that depending upon that thing also welding is categorized. Now depending upon what is called composition of the joint, that means whether it is autogeneous, heterogeneous, or homogeneous types of welding process. So depending upon that thing also welding is categorized. Depending upon the position, generally position of electrode, welding is categorized. So depending upon a mechanism means whether it is a what it's called automatic, semi-automatic, or manual types of welding process. Depending upon these things, generally welding is categorized. Now you should have detailed idea on this. Then also you can choose a what it's called correct welding process for a correct project. Okay, so little bit I am showing just one of the category. You can see this is depending upon the source of heat, how we can categorize the welding process. Like arc welding process, here the source of heat is welding arc, that means electric arc. So here so many different categories of welding process are there, you know very well. Like some source of means heat in case of welding as gas. So many categories are there. Similarly, resistance heating, then thermochemical welding process are there, mechanical engineering, mechanical energy welding process are there, and some other advanced welding process that is generally considered radiant energy welding process like electron beam, laser beam. These are the different categories of welding process are there. Now, for what types of application, what types of welding process you should use, little bit I am just briefing here. I am not going in details to discuss about all these things, because if I will go to discuss about all these things, it will take, I have already told you, for one welding techniques, it takes one lecture. So here I am just briefing this thing. So I am giving you some very fundamental ideas, so that immediately you can get a idea, that means for a particular path of what types of welding process you should use. That's why I have written here. You can see the selection of a welding process depends on number of components to be fabricated, what is the capital equipment cost generally considered for that project, what should be the joint location, what is the volume of that structure, what is the desired performance of the product, and what should be the desired performance of the product. So depending upon that thing, generally you can use your welding technology for a specific types of purpose. Like here you see this shielding metal arc welding, one of the example I am showing. So what happens, let's you have a work, we have a project which is related to maintenance and repairing related things. Okay, so once there is a maintenance and repairing related thing, so initially you can say that, okay, here we can use a welding process whose name is shielding metal. So that types of way I have grouped these different types of welding process. Okay, so the like construction of steel structure, there you can use this welding technology side successfully. Similarly, let's say submerged arc welding process. Submerged arc welding process, once you have a project which are related to pressure vessel fabrication, shipbuilding industry, pipe manufacturing, railroad construction, so at the first attempt you can say here we can use a welding process, that is submerged arc welding process. What I'm telling, understand? So that way generally I group this welding process so that you can have an idea beforehand that what types of welding process you should use for that specific welding project. Okay, so here I have shown here like gas tungsten arc welding process. So to see the quality of work, you can immediately say what should be the welding process for that purpose. So I have grouped all these welding process in that way, like flux core arc welding process. Here you see plasma arc welding process, electroslag, electrogas, oxyfuel arc welding process, where you should use all these things. Similarly, here you can see friction welding, diffusion welding, friction stir welding process, ultrasonic welding process, explosive welding process, then electron beam, laser beam. So you see, so where is its potential application? So beforehand, you can get a very brief idea from this, what is called detailing of welding technology selection in appropriate welding projects. Now I am going to discuss about some basic of welding joint. You see, so before going to discuss about this welding oriented defects, welding oriented safety, welding oriented quality and all the things, first of all, you should know some basic fundamentals of welding welding joint. After that weld joint, you can say, after that we'll discuss rest of the thing one by one. Okay, like you see, some basic point you should know are related to weld joint, like what is joint root, what is groove face, what is the root face, root edge, root opening, and all the things. Okay, these are the different types of terminology generally we very frequently we use. So to handle a welding oriented project, first and foremost things you need to know this basic terminology. Because what happens in your welding process, generally these types of, or welding drawing sheet, these types of terminology will very frequently come. That's why you should have a very fundamental idea of all this terminology. So I will just give you this fundamental things. After this, rest of the things I will discuss. Like you see, detailed nomenclature here I am showing of a bar and fillet joint. So to see this name itself, you will have an idea that somewhere it is written these types of terminology. You can easily recognize what is the things here they want to tell. Okay, like for a bar weld joint, here you can see what is called bevel angle, what is called included angle, root gap, root face, top side, root side. These are the things are very much essential to know what I am telling. Understand? That's why I have written here. So what is a bevel angle? You see, bevel angle means with perpendicular line. What is the face of the, or you can say faying surface of this welded joint makes the angle, makes an angle. That angle generally called bevel angle. What is groove angle? Groove angle means the angle in the faying face is called the groove angle. Now you see this is generally called groove angle. So from this diagram itself you can get an idea what is the bevel angle, included angle or groove angle. What is the joint face? That means what is the joint face? What is the root face? Root face, what is root actually? Root, little bit this you should know. Root face means is a face to face of two plate where the distance between these two plate is minimum. Like here you see this is a bevel angle. Here the distance you can see in case of bevel angle types of joint, the distance in between two plate is more at top side, and distance in between two plate is less or minimum at bottom side. Here you can say. So these distance generally where the distance between two plate is minimum, that portion is called root face. And whatever the root in this root face, whatever the thickness generally we consider in this root face, that is generally called, you can say, root height or root face. That also you can say. Here I am telling face because what happens, there is a surface. Here I am showing that front view only. So that's why what happens, you can see here is a surface. So and this is generally you can say root face. Here these things also called root edge also you can say. So in between these two generally what are the at root position, whatever the distance is there, that distance generally is called root gap. Why these things is required in a weld joint? You are very well familiar with of this thing. Then also you should know that what happens, your final weld joint should have some bottom reinforcement as well as there is some top reinforcement. So what happens if this types of root gap is not there? Generally, in some cases, root gap is not required, but in some cases, this root gap is required, because if this root gap will not be provided, then their molten material will not be able to pass through this gap, and it will not be able to make a bottom types of reinforcement. That means there is a bottom types of extrusion, you can say, of that weld material as there, as well as at top side also there is some convex types of shape. You see, that means at bit height you can say is required. That types of things you will not get if this well geometry or well joint geometry is like that. That's why these types of terminology you should know. Similarly, here I am showing some different terminology which we use in case of what is called flat welded joint. So you see, flat welded joint means a flat welding shape is, whose shape is like a triangular type of shape, you know. Now this triangular shape, what is the different part of this fillet welded joint, that also you should know. Generally here you see this corner point of this triangular types of weld is called this toe, which is a very critical point you can say in case of welding, because what happens here, there are coming different types of stress concentration, different types of welding oriented defect. That's why this toe terminology you should be very well familiar. Generally this you can say hypotenuse, what it's called, this edge is generally called face of the weld. Okay, and this what it's called, this base and height face of the weld generally is called leg of this weld. So these are the things you should know. Why you should know this thing? Because what happens once you go to see the detail about standard and code used in welding, there generally they will use these types of terminology. That means what should be the leg length, what should be the toe height, what should be the face weight, and all the things. That thing generally we use on this what it's called in code and standard types of in rule book of code and standard. So they are generally these types of terminology we use. So what are those things, that related things you need to know? Okay, so that's why I am showing these things. Little bit. So little bit next slide. I am just going little bit other things also you should know. Like you see, I have already told you single V bar joint. What are this included angle? What is this bevel angle? What is this root face and all the things. Similarly, for generally thick section in the sense like where the thickness is little bit higher side, that means 20 millimeter, 50 millimeter, like this level of thickness is there. They are generally, instead of using this V group types of weld, if we use J group or U group types of weld, generally there we can generally get lot of advantages compared to this V group weld. So in this J group or U group also there are some terminology which you should know before going to discuss rest of the things that I am just telling. Here you see, like here you can see that in case of single U bar joint, generally this is called included angle. This is generally called root face. But here some extra term is there. This is called root gap. There is a root radius is there, and there is a land. What is called land of this root radius is there. Generally from here to this root radius position, there is some flat position is there, that is called land of this U joint. So here we have not provided this thing, but these are the things you should know. Now, why this little bit I have discussed about why this double V bar joint or single V bar joint or double U joint, double V joint is required. Because you see what I have already told you, generally once the thickness is little bit higher side, generally there we use double bevel, or you can say double V joint. Generally if we use a double V joint, there we can get lot of benefits. In the sense, here generally we can reduce the weld material drastically, as well as we can reduce some other unwanted defects, or you can say unwanted residual stress, distortion, we can minimize drastically. But what happens here, the problem is some structure which is not very easy to invert. What happens in that case, generally what happens, this double V or double bevel types of bar joint is difficult to implement. There generally we can use some U or J group types of joint. Okay, how it is that I am just going to discuss. This what happens, so here also double J, double U also we are showing. Okay, how it is that I am just going to discuss. So first of all, here little bit I am showing for a particular thickness of plate. If you use a single V types of joint geometry, there whatever the weld material will be required, generally if you use a double V bar joint, there you can reduce that weld material around half of that single V bar joint. What I am telling, understand? Like what happens if you make 4 triangle in this single V, here you can see you can get 4 triangle like this way if you just divide. So whereas, so here 4 different triangle you are getting, whereas in case of double V bar joint for same thickness, you can do these things by using 2 triangular types of flare material. What I am telling, understand? So here the volume of flare material you can reduce drastically around 2 times of this single V bar joint. Okay, but here the problem is generally there should be feasibility of inverting of this weld structure, because what happens in some cases, let's you have a very big block of ship structure is there. So what happens is weight will be 100 ton. What happens to invert those types of structure to do these types of things is very difficult. So there, so where you should use this double V bar joint, where there is a possibility of inversion of that, what it's called inverting of that welded structure is there. What I'm telling, understand? Now, so what is the advantage of and drawback of this U and J group? I have already told you, generally in case of U and J group, generally you can imagine that you can reduce the volume of filler material also drastically, because here generally instead of making the A's like Vivel type, V type, here we are making which is almost parallel to each other. You can see this thing. So here generally volume of filler material also here reduced drastically, as well as here as the filler material reduction generally distribution throughout the entire thickness of the plate almost uniform. That's why what happens here, whatever the expansion and contraction phenomena taken place, that is also almost uniform in nature. Due to that things here, generally chances of residual stress and deformation is less compared to single V types of bar joint. What I am telling, understand? So here, but here is a disadvantage also, because to make this J group or U group, generally there is required a very costly machining operation before, and which is a time consuming machining operation also. Apart from these things, generally in these types of welding process, if the thickness is very high, then there is a chance of what of lack of side-wall fusion. Lack of side-wall fusion means why? Because once we use this electrode, generally electrode, or you can say this filler wire, generally this arc generally have a chance, because this arc is generally through the perpendicular direction. So at side wall, generally there is a chance of lack of fusion if the depth of this J or U group is very high. That's why your J and U group also have some limit. That's why sometimes double J or double U group is also required to make. So this is the generally advantage and drawback of this J group or U group compared to V group. So what is the drawback here? They had then can be required costly machining and time consuming machining operation. And what happens, there is a chance of lack of side-wall fusion. But it has lot of advantage in the sense air filler material requirement will be less, air deformation will be less, air what it's called residual stress and other things also will be less. Now I am going to discuss some other little bit fundamental things, because these are the terminology will come in project management and all the things. That's why I'm just telling. Like what is backing stiff and backing bar? Because what happens to do the welding, generally what happens to support the filler material, we should not pass throughout the bottom side of this workpiece material. Generally we provide some what is called provide some backing support, you can say. This backing support it has different name, you can say. This backing support, one is called backing strip, another one is called backing bar. So this is a backing you can say bar or backing strip. Generally what is called backing strip and what is called backing bar, little bit I am just telling, because these types of thing we use in different types of drawing of welding. What I am telling you, that's why I am just telling this thing. So generally this backing strip generally makes a integrated part after welding. That means you need not to remove after welding this extra supporting part. Okay, but backing bar generally which is recyclable. Like recyclable means you can remove that things again you can reuse for other purpose. Like for submerged arc welding purpose, we very frequently use this backing bar. Okay, so little bit these things you should know. Some other fundamental things also you need to know, but the detail about this thing is written here. So what are those other fundamental things? Like in welding, generally there sometimes we need to join different thickness of plate. So to join different thickness of plate, what are the precaution or what are the aspects we should consider, so that the abrupt change due to this different thickness of plates we can avoid? Because you know these things, this where there is a abrupt change, there is a chance of what it's called, there is a chance of what it's called stress concentration. Once there is a chance of stress concentration, then there will be that means if it's subjected to fatigue oriented loading, then what happens is service life reduced drastically. To generally overcome those things, generally we can use a process that is called transitioning. What is this transitioning? Transitioning means you can say here we used to make the thicker plate section by a taper shape. So this taper shape should be such so that it should not affect the fatigue life of that structure, or it should not affect the stress concentration orientation phenomena of that structure. So what is this transitioning? Little bit I am just discussing here. Like here you see that this is on thin plate and this is on thick plate. With this thin plate, we want to join this thick plate, correct? So to join this thing, if you just directly put the welding here, then what happens here? There is, you can see there is a abrupt change is there. Corner point of this welding is there. You can see. So here there is a chance of huge stress concentration, correct? So what happens, to eliminate these types of stress concentration effect, what we can do, we can use this transitioning technique. What is this transitioning technique? Transitioning technique, generally, you see this thicker section, we are making a tapering. You can see we are making a tapering. What should be this tapering length? What should be this tapering length, so that your stress concentration will be less, as well as it will not hamper the fatigue life of that structure. So that is generally called transitioning. Transitioning is like what happens here. What happens? We want to reduce the this high thickness plate at a thickness of, let's this T. So from where this tapering we should start, so that your stress concentration will be less. If this length L is equal to minimum 40 of this 4 times of this T. What I am telling, understand? That means we should start our tapering from such a position. If this L is equal to or more than this 40, then you see in this welding position, generally your stress concentration will not affect the fatigue life drastically. So that is called, that is a very important term which we very frequently use in industry. That is called transitioning, and that is also have a name, that is called 1 in 4 taper. This 1 in 4 taper generally we require to use for different types of what is called thickness of the plate. That means to reduce a particular generally thickness, what should be the length for a starting of the taper, that you should know. Okay. Now I am going to discuss little bit about the generalized welding symbol. After that, generally rest of the part I will discuss. You see, this is a very big topics. So this is very difficult to cover within single lecture, but I will try to cover it actually very briefly. So you see, to be familiar, you can say, with the welding oriented drawing, what are the first and foremost things you should know? The first and foremost thing we should know is this generalized welding symbol, because generally in a welding structure oriented drawing, there you will get these types of some line, and there are some wording. What happens, to see this word and line, you should know what are the things required to do for that welding project. So that's why this generalized welding symbol is a very important part in project management related things. Because if you don't have idea of this generalized welding symbol, you'll not be able to understand the welding drawing we generally use in industry. That means by this simple generalized line, we can represent what should be the welding process, what should be the welding type, what should be its specification, and all the things in details. What I'm telling, understand? So this is generally a generalized welding symbol. You can see. So this horizontal line has a name, that is called reference line. So you see, this is generally called tail of this generalized weld symbol. You see, now in this tail, generally whatever the different types of specification and reference we use, that things is provided. And this reference line generally have top side and bottom side. This top side of this reference line is called far side detail, and what is called bottom side of this reference line is called arrow side detail. So how it is, little bit I will discuss by giving some example. You can see, let us this is a fillet welding you need to do. So here your fillet welding should be this side. So if you use a welding symbol which is at this side, then what should be the welding symbol here? Little bit I am just telling. So here you see, Here the arrow side means in which side we are providing the arrow. Arrow we are providing right side. Okay, so arrow we are providing the right side, but I have already told you this is the reference line. Horizontal line is called reference line. Whatever the things will be below this line, that will be the details of arrow side, and whatever the things we will provide above the reference line, that will be related to other side of the things. What I'm telling, understand? So here I provide the arrow in that side where welding is not required. So you can see this is the reference line. So arrow side I have not provided any welding symbol, but other side or far side there is required a fillet welding. So that's why I have provided fillet welding here. Now this fillet welding, let's it has a leg length of 6 millimeter. This 6 millimeter generally is required to put left side of this thing. So in generalized weld symbol, I have provided the detail of this information here. Okay. So here you can get the detailed idea about all these things. Okay. So I am not going in details of all these things. So these are the different symbol we use for in welding drawing. Like for a square group, we use two parallel line. Similarly for bevel group, like bevel shape. So then V group, V shape. If there will be required backing, then backing shape is like this. Okay. So these are different types of example here I am just showing. Some other information also given here related to welding symbol that you can see from this lecture slide, because this will be provided after this lecture also. You can get the detailed idea about all these things. Little bit some other things also here I am telling related to multiple types of let's you want to do some multiple pass of welding through the thickness, not only single pass of welding. So to do this multi-pass of welding, how to represent in a welding drawing, that is also here you can see. Generally, so multiple operation. Generally, first operation will be which is closer to this arrow location. Second operation will be further away from this first operation. Like third operation will be further away from this. If there are some other operation are there, so fourth operation will be here. What I'm telling, understand? So always you should keep it in mind. Let's here you see this is a another example I have shown. So close to arrow, whatever the operation will be there, that will be the first operation. Away from the arrow, whatever the operation will be there, that will be the subsequent other operation. This you should know. Now in case of welding symbol, generally we use what is called a straight arrow and broken arrow. A straight arrow means where there is no breaking like this. What when you see here the arrow is coming here, after that is break like this. It's break like this. Sir, sir, sir. ঠিক আছে স্যার। ও অভিষেক আমার 1.5 ঘন্টা না স্যার? তাহলে? ও আচ্ছা, আচ্ছা, আচ্ছা। ও তাহলে স্যার ঠিক আছে, ঠিক আছে, ঠিক আছে। আমি তাহলে ওকে স্যার। ঠিক আছে স্যার, ঠিক আছে। Okay. Actually, I was thinking my time is 1 hour 30 minutes, but my time is only, I think we have 2 lecture within this 1 hour 30 minutes. So, okay, then fine. I will discuss about the other thing. So these are the related to welding symbol. Okay. Now weld quality. Here you see. So generally, quality of weld includes design consideration. Generally, a weld quality is highly depends on its design consideration. What are those design consideration that we should know? So to get a desired quality, generally these following what is called criteria generally are required. What are those following criteria? Little bit I am just discussing, because to get a good quality welding, generally the first criteria we should consider is design consideration. In this design consideration, you see so many different aspects are there. Okay, so similarly there should be some fabrication consideration, there should be some inspection consideration, and there should be some operation and maintenance consideration. To get a desired quality welding, generally these are the following criteria we should follow. Now what is this welding quality means? Little bit I am just telling. This means welding quality means it has a good quality. What is a bad quality welding? What does it mean? Good quality means where the number of defects is less. If the quality is what it's called bad, that there is a chance of number of defects is more. How it is little bit in subsequent slide I'll discuss. So specifying a very good quality or excessive quality of welding is not a good criteria, or specifying a very bad quality welding or low quality welding also is not a good criteria. That's why to get a good quality or optimum quality welding, there should be proper this following aspect consideration. What I am telling, understand? That's why here I have written, specifying a excessive quality of a product is not a good thing. It can lead to high cost, but it has not very high benefit. It has some few benefit. Similarly, specifying a low quality weldment also can lead to high maintenance cost, as well as what happens, it can have high number of failure also. So how this quality generally we can quality of a welding we can inspect or test, that related things I am just going to discuss. Now you see, two generally you can say the weld quality is generally affected mainly the discontinuity present in the weld. What are those different discontinuity? You are very well familiar with these things. That is generally called welding flaws or welding defects, you can say. What is welding defects or welding flaws? Little bit I am just telling, and what are its different categories also I am showing here. Like here you see, in welding defects, generally what is called a defect? Defect means once a welding has some particular defects, it generally goes till its what is called defective weld means it goes to its failure limits. Generally, in case of welding, what we quality measure, we measure the flaws of the welding. That you can say. Flaws means that is also a discontinuity, but what happens, which is not goes to its failure limit. That means which is in the acceptable limit. What I am telling, understand? So here I am just showing, that means that's why instead of using the term defect directly, here I have used a term that is called discontinuity. So in fusion welding, there are different types of discontinuity which you can arise. These are generally what is process-oriented discontinuity. There can be metallurgical discontinuity. There can be design discontinuities. In the case of solid welding also, solid state welding process also, there are different types of similar discontinuity are there, but it has little bit different type. What I am telling, understand? Now these defects have tremendous effect on this quality. So to predict this defect, generally what are the different things we use? Different things, there's the different things we use, that is generally called welding inspection and testing of welding. Okay, so what are the different types of welding testing method and welding inspection we use? Little bit I am just discussing here. After that I will discuss what is called quality assurance and all the things, because time is very less. So what is inspection and testing? Testing generally is done for a specific, which is follow a specific standard in some certified laboratory. Whereas inspection generally, you know very well, generally inspection typically takes place at an industry where the product are made. So it generally involves checking a random sample of an order for compliance with a buyer requirement and a specification. That also you know. Now, what is the requirement of this inspection? Generally, to assess the property and quality of this welded joint, and what is the whether this welding is suitable for that particular object or not. That also we can predict by this inspection and testing procedure. There are generally, in case of welding inspection, you see this welding inspection is not only done before welding or during welding. Throughout the entire service life of the welding, whatever the different types of, you can say, quality control activity we carried out, that is generally consists of a series of welding inspection related activity. So this welding inspection generally is not done by a general person. This is generally done by a qualified and especially trained personnel who must have a working knowledge of applicable code and standard. By them also, them only we can inspect this weld quality. So this weld quality, generally inspector should have a certificate from some very well-known certification society. So some of the certification societies names here I have shown, which generally provide the certificate of a welding inspector. Like here you see American Welding Society, CSA, Canadian Standard Society, ANSI, AWS. So these are the different types of society are there. From there, generally, you can get a, what it's called inspection certificate by tracking some qualifying exam. What I'm telling, understand? What are the different classification of this welding testing? Little bit, there are different types of classification, destructive, non-destructive, NDT testing. So this testing can be workshop testing, it can be laboratory type testing. So there are different names and all the things. I will provide all the things. What are the different types of testing are there? This is NDT testing. You see visual testing, what is called magnetic particle testing, dye penetrant testing, radiographic testing, ultrasonic testing, acoustic technique, and what is called water pressure testing. So what are the different aspects generally this inspector inspect to assure the quality of the welding? That little bit I have pointed out, like inspection prior to welding. Generally, what are the inspection we used to do? So you to get a quality product, first of all, foremost things, we should follow these different steps. Like inspection prior to welding, we should do so many different types of inspection of a welding, welding related sample. Inspection performed during welding. What are the different types of inspection required to do? That also here where I provided. What are the post-welding inspection are there? That also you can see. That means whether once your welding quality will not be good, then what should be its next step to make it applicable in service life. That related things here I have provided. Okay, you can go through this. Now, welding safety management is a very important issue in welding that you can see here, because so many different types of hazard you can face in welding related industry, that you can say it can be due to the fume and gases, it can be physical hazard, it can be electric shock, it can be fire explosion, radiation, noise, compressed gas. So many different types of welding hazard are there. How we can manage this welding related this hazard, that related things in details here I have specified. Like what are the different types of hazard, and how it's what are the proper steps we should take to remove or eliminate these types of hazard. Everything in details I have written here, like hazard notification and positioning of the equation. What are the different types of hazard protection related activity we should do? Here I have written. Machinery safeguard. In case of machinery safeguard, what are the different safety aspects we should follow? That is I have written. What are the protective booth generally where welding is done? How we can protect this thing from radiation and all the things. Everything is here I have written. Then wall reflectivity, where we are doing the welding, what should be the wall characteristics, so that your it should not affect the what it's called general person. What I'm telling, understand? That means your reflectivity or ultraviolet reflectivity should be as less as possible, like this. If your welding related machineries if exhibit for public exhibition or demonstration purpose, what are the different types of safety measure is required to do? Everything I have written here. This is, you can say, a safeguarding device which we use for doing a welding of a welder. What I'm telling, understand? So the details as here I have provided. So now I am going to discuss little bit quality assurance. What does it means? Within another 5 minutes, I will complete these things. So in quality assurance, when generally in welding, it involves implementation of procedure and processes, generally which ensure that the welding process and its result meet the requirements, standard and specification. So that thing generally is assured by this quality assurance procedure or quality assurance activity. So as per ISO standard, you can see what are the different things we should follow to get a quality assured product. So you see here I have written 5 different points. You can see the first point is like a product should be quality assured if we follow the features of the finished product. That is, if the finished product is able to satisfy the implied need. And to get a quality assured product, generally setting up an implementation of plan directive to achieve that required quality. So some points there I have written. Once you go through this, then you can get an idea about quality assurance in welding. What I'm telling, understand? So here you can see there are different factors which affect this quality assurance procedure. What are those different factors? Has I have generally means summarized in details here. You can see like this the effect of quality of a product is generally affected by the material, it affected by a stress, it affected by welding process and procedure, geometric effect, environmental effect. So these are the things in brief and point wise I have written, so I am not reading all these things. But these factors, once you consider during your quality assurance procedure, then your quality and final product will be satisfied the required service and quality. What I am telling, understand? Now you see here I have written some code and standard which we need to follow during this quality product of especially for welding purpose that I have written here. So generally we know this code and standard which describe the technical specification required for a material, process, product, system or service. So generally this code and standard we need to follow during the entire welding operation. It's because what happens without following this code and standards, if you do some welding job, then your final product may not be acceptable in classification society and it can be rejected. So to do a project, generally a welding related project, we should follow this code and standard. This code and standard generally provided by different organization. Here I have shown here, you see, the code and standard, if you will not follow, you will not, your final product will not be acceptable for actual service. What I am telling, understand? So before going to do any welding product, manufacturing any welding product, we should follow this code and standard, and based on this code and standard, we should start our work and do the welding operation and do the final product. What I'm telling, understand? So you see here I have shown around 16 different number of organizations which provide these different types of code and standard are there. Now this code and standard in welding you will find like for you can get a standard for consumable, you can get a standard for welding procedure, you can get a standard for welding welder approval, we can get a standard for quality of a completed types of fabrication. So to use a particular consumable for a particular types of welding process, you should follow this standard. If you will not follow this standard, if you arbitrarily choose a particular consumable and do the welding, your final product will not be acceptable. That's why what happens once you go for doing any types of welding operation, first and foremost things is you need to follow this standard. Like a standard for quality consumable, just here I have written what are the different types of standard we follow during quality consumable types of standard. Just you go to this BSc 639. Here you will get for manual metal arc welding what should be the electrode we should use. Similarly for BS 4165 for submerged arc welding use, what types of consumable we should use for a particular types of material and all the things. So whatever the standard there is provided, we should follow those things. After that we should do the welding operation. What I'm telling, understand? So this is different types of standard for different purpose are given. So what happens, we should follow during welding project all this specification, then only your final things will be acceptable in classification society or the approval authority, you can say. Now in welding generally how the cost estimation is done. So for cost estimation, the primary things you can say is called the WPS sample. So this you can consider a primary sample for cost estimation of welding. This WPS, you should know this name generally because this WPS provide you the detailed variables required in a welding operation. So and you have the detailed specification, materials and all the things here you can get from this WPS specification. So if you follow this specification, based on this specification, generally you need to find out the economics of welding. Little bit like what are the different factors affecting the cost estimation, you know. There can be direct material, direct labor, expendable equipment, factory overhead, variable in welding, and computerization in welding. So what are the different types of factor affecting the overall cost of a welding product that I have shown here. So I am not reading all these things. You just go through because time is very less. So I am not, then you see in quality cost, generally in the cost estimation, this quality cost is required. Here prevention cost is there, appraisal cost is there, internal failure cost, external failure cost, welding cost control related cost also are there. So these are the aspects we should follow for estimation the cost of a final welding product. What I'm telling, understand? These are the following references I followed to make this talk. Thank you so much for giving me this opportunity to. But what happens? This is such a topics. To get a detailed idea on this, we should have at least more time. Okay. Thank you so much. If you have any question, any query.
Thank
Can.
you, Dr. Biswas.
Sir, thank you so much.
Thank you very
Because
much.
I was
And
thinking, sir, actually, I was thinking my time is 1 hour 30 minutes.
no,
Okay.
you combinedly it was 1 hour
Okay,
30
two
minutes.
lecture,
Anyway,
two
yeah.
lecture. Okay, fine, sir.
Now I request Mr. Abhishek Mukherjee to continue the lecture
Yes.
on AI. So, Mr. Mukherjee, are you there?
Yeah, am I audible, sir?
Yeah, you are audible.
Hello. When I can put up question to Professor Biswas?
Sir,
Uh,
anytime, sir. After that also you can put.
Okay,
Yeah,
okay.
after Mr. Mukherjee finishes, then we'll open question answer session for both of them.
Okay, thank you.
Thank you.
Okay.
Okay, so should I start, sir?
Yes,
Yeah.
yes. Now,
Uh,
a little bit, sir, I am telling, Abhishek will discuss the very latest, what you can say, modern application of machine learning and artificial intelligence in the field of welding, sir. So he will discuss what is this modern technology, or you can say machine learning, artificial intelligence in the field of welding. He will explain these things in
yeah.
detail, sir. Okay, thank you.
So, Dr. Biswas, can you stop your screen
Yes.
sharing? Yeah.
Yes, sir. I'm sure.
Yeah. Now, Abhishek, you can start. Right.
Yes, sir, I'm sharing. Sir, is it visible?
It's visible.
Yeah.
It's visible. You can continue.
Yes.
Yes, continue.
Very good afternoon to all of the attendees, professors present over this platform. Thanks to Professor Enar Mandal sir for inviting me for this talk. Let me introduce myself. I am Abhishek Mukherjee. I am a doctoral scholar working under Professor Surjakanta Pal in Advanced Technology Development Center, IIT Kharagpur. So today's topic of my presentation is use of artificial intelligence in welding technology. So let me discuss the content first. So first I will tell about the what is AI and what are the domains of AI, and then I will tell about the its industrial applications over various type of manufacturing verticals to give a feel that what are the spread of AI over the other verticals other than welding, such as machining, casting, forming, additive manufacturing. Also, as a quality inspection is a very required thing in industry. So thus I will tell a brief of what are the applications of AI in quality inspection in industries. And then we should also know that where we are, like why today's AI is lagging to satisfy all the manufacturing requirements. And then as the topic is AI application in welding technology, so we need to see the automation, evolution of automation in welding. And as AI comes as a part of the automation, like evolution of automation needs to be understood. So these are some of the parts of automation in welding. And then, sir, I will discuss that what are the scopes of today's welding industry of AI, and then I will discuss about some of other our works in our lab. So this will be my contents of my presentation. So basically, what is AI? AI is a basically mathematical tool. So if you give a input and a output, set of output, it will try to find a function between them, that is called training. And in case of testing, it will use that function without any output, like it will try to produce output without any in uncertain environment or unseen situation. Actually, AI is a full form is artificial intelligence. So it is actually mimicking the our human brain. So as you can see, we do have sensors like our nose, eye, ear, like we can touch, we can our tongue. So these sensory inputs are coming to our brain, and then our brain analyze it, and then it will try to incorporate our actuators. That means our hands, our legs, to encounter unseen situation. So this is a human activity. So similarly, sensor inputs are given to AI as you as I have told that it is taking inputs. So these are basically inputs from the sensors, and based on the sensors input, it is solving, it is creating a mathematical function, and through it the sensors inputs are passed, and it is producing some output. But the question is, can AI solve the unforeseen situation like human being? The answer is no, because AI is mostly supervised. But a human, like for training of AI, we need so many data. It is mostly data centric. But we human, if we see our image, we can recognize similar type of image very quickly with a very less number of inputs. So that's why a new term is coming up nowadays, that is cognitive intelligence. But anyhow, today's AI is so useful to meet the requirement of industries. So that I will discuss. So like if I give you an overview of AI, like it needs to understand the data, and then it needs to understand the what are the features incorporate like inside the data. Raw data is sometimes not useful. We have to deduct some features like kurtosis, skewness, mean, standard deviation, this kind of, which can be correlated to the output far better than raw data. So those we need to extract, and we need to train the model or AI. And then after training, when the model is performing good, then we can engage the AI, trained AI, with the physical system, so that physical system, in the physical system, it can give a decision through which the physical system can actuate. So if I give you a an example, that this is a drilling process where several experiments has been conducted, and as you can see that as you can see that this change in drill in a signal of current is actually presenting the breakage of drill. But for a human being, it is not possible to observe data continuously. So we need to feed this kind of data to AI, so that AI can automatically predict that, okay, if there is an abrupt change in this signal like this, then there can be a possibility of drill breakage. And then the decision can be fed to the so there is a trend like this. So if this kind of trend is coming up, then AI can automatically tell that in within this kind of second, 1.5 second, or maybe within 5 second, 0.5 second, the drill is going to break. So the AI can send the parameters to the machine, and machine can automatically change the parameters to increase the longevity of the drill bit. So in this way, AI is working actually, and it can be integrated to any kind of manufacturing system. So these are the domains of AI. Basically, I have told already that AI is basically mimicking the human activities. So these are some examples that what AI is exactly mimicking. So if you see that human can actually listen and recognize, this is basically a part of speech recognition. That is a domain of AI. Voice assistance with workers in manufacturing shop floor, like a person is giving order to a robot is doing something. Similarly a person can listen and he can write. That is a part of natural language processing. That is also a domain of AI. The inventory management, consumer behavior analysis, these are some applications of the uh, natural language processing. And the most applied AI domain is computer vision. Like it is mostly applied for quality assurance in industries. So it is actually mimicking the human ability of seeing and analyze. These are used for assembly inspection, defect identification, barcode reading, etc. Robotics also a part of AI, not a directly a part of AI, but intelligence put in the robotics. Those are actually mimicking the dynamic movement of human. So robotics is used mostly painting, welding, gluing, machining, machine tending, material handling, and there are several tasks is incorporated using robotics in manufacturing industries. And lastly, human brain. Human brain is the most complex thing of our body. So today's artificial neural network and deep learning are deeply inspired by the human brain. But this machine vision, computer vision, and all these things, they are taking a small part of the human brain, and artificial neural network is used in all of them. So they are used in several tasks like object detection, worker safety analysis, quality assessment, and these are the some applications. So if I go for the AI application in quality inspections, like some of the use cases I am showing, computer adapter inspection. So computer adapters, people are doing manually inspecting after producing. So as it has very small components, so they are taking so much time. So AI and machine visions, they are automating it. They are actually detecting computer adapter, like where the if the ICs are present or not in the proper place, if the soldiers are broken or not, like that. And there is another use case like spark plug dimension checking. As you can see that, I don't know. Yeah, as you can see that this gap is having some standard through which, like, if it is more than it is a no-go image, that means this spark plug can be rejected. Otherwise, if it is within tolerance zone, then it is accepted. This kind of camera can be placed, taking the image, and it can be analyzed that what is the distance. Based on that, it can go for rejection or it can be accepted. So this kind of applications are there. Similarly, engine component matching, barcodes are there. So I have told already that machine vision is used for reading barcodes. Engine block traceability. So in which assembly line it is going, or is it going properly or not. Stamp product. That means where each and every corner of the tailor blanks or doors, those are properly stamped or not. Whether there is any dimensional deviations. And nowadays, workers are doing it within limit gauges, and those are time consuming. So machine vision can do the tasks very easily. Then why we should not go for automation? And then patterns inspection. These are some application of AI in quality inspection. So now I am describing the application of AI in manufacturing verticals. The one of the most critical manufacturing vertical is machining. Real time monitoring of state of cutting tool. This is an old age problem. Researchers are still doing it, but industry is unable to accept it because AI is not that capable that if you are doing it for a machine, the same model can be used for other machine. So for every time you are changing the tool material combination and you are changing the machine, you have to change the AI. So, and for the changing the AI, you have to train with a lot of data, and producing a lot of data is a very big task. So there is a scope in this also. Then like state of the cutting tool, we can also see the surface roughness, material removal rate, cutting zone temperature. These are the some factors which is deciding the quality of the workpiece also. And there are like real time control of robots of loading and unloading workpieces. That means like robots are nowadays taking, instead of human, they are loading the workpieces. So we have to control the robot using AI. And similarly, health monitoring of the gearbox of lathe and all. Those are some the scope of AI application. In any health monitoring can be done using AI if we put sensors over a machine. Similarly, in casting, you can see that blue holes and other defects are present on the cast. So you can take a webcam and you can take the image and feed it to AI. I can tell you that these are the defects present. Similarly, mold inspection in for allowance, like allowance in the molds can be inspected using AI. Similarly, gauges are actually used by manually. So those are time consuming. So AI can save a lot of time. Similarly, real-time information like of what is the solidification rate is going on. So this I have seen in ISCO power plant, ISCO steel plant. So they have told us that this problem they are facing, that they cannot control the solidification rate and pouring time. So this can be done using AI. So this is one industrial problem. And also like robots are there, so we can control the robots anyhow with AI. Similarly, scopes of AI in forming. So form, tool, and die. What are the defects occurring with those? What are the health remaining? So those are problems of scope of AI in forming. Similarly, we can inspect defect in forming also using AI or machine vision. We can monitor temperature. We can make decision that using temperature curve and AI, that what is the quality of forming going on. And similarly, robot can be used. So that is also controlling robots for forming is a scope of AI. Similarly, in additive manufacturing, it's a new, AI is also a new thing, and additive manufacturing also a very booming area. So we can automate the 3D printing workflow and control the sequence of printing. So it is a very large structure, and there are so many parts. So how we can control the sequence? So for tool that scheduling can be done using AI to reduce the downtime. Similarly, from a pre-designed prototype, what can be the strength of a product, and if we need to change the design or not accordingly, so that we can predict using AI, and we can get a optimized quality product. Similarly, like we can optimize the manufacturing variables of this additive manufacturing, like acceleration, position, those things. And similarly, defect analysis before printing, that if I go for these parameters, whether these defects will occur or not, like this we can do using AI. Supply chain management, we can do warehouse logistics like packaging, movement. So this already AI is, I think, well established, but in some of the industries they are not using. But this technology is mature, that warehouse logistics, transport optimization, smart production, and autonomous vehicle, these are some uh, specific application of AI where we are putting intelligence to several use cases in supply chain management. Now coming to where we stand today, as I have shown that AI can recognize any kind of object, and this property can be used for various type of defect detection, material handling using robot, and all these things. Similarly, any kind of, I have told, wherever some faulty products, faulty machines are there, you can put sensor, you can take data, and you can like predict the machine health. Similarly, optimizations can be done using AI, so that we can get a optimum quality of the product. Like it can be welding, it can be machine or anything. Similarly, tool path optimization for additive manufacturing, for robots, for machining, CNC, and all this can be done in present. These are all mature technologies. But what we yet to achieve, collaborative robots are used, but robots are not properly collaborative robots are there, but in manufacturing it is not mature, because there are so many obstacles here and there. So, and very uncertain environment, so it needs to be more intelligent. AI needs to be more mature to be integrated with collaborative robot. Self-learning machines. I have told already that in tool condition monitoring, it cannot be implemented in industries right now, because uh, they are not self-learning. With the if I change the machine, there needs to be learn again. So from the data, AI needs to be learn automatically, so that it can be implemented anywhere. Hybrid digital twin. This digital twin term is a buzzword today. It is actually replicating the digital form of a process or machine, which will tell you the real-time health of a machine or process, or what is the performance index of a process. And what is hybrid digital twin? It is actually encountering the physics of a phenomena as well as physical sensor data. Combining those, if AI can be trained, that is a hybrid digital twin. Similarly, adaptive monitoring and control. So these are the things to be achieved. These are not, people are working on that, but these are not mature technologies. So as the concern of this presentation is is use of AI in welding. Thus, evolution of automation in welding is a must, because AI is coming with the automation, evolution of automation in welding only. As Professor Viswas has already told that what are the types of welding people have adopted already, but mechanical assistance initially in the starting era of the welding, there are mechanical assistance, and then semi-automatic wire feed has been automated, but there are also manual switch pressings are there, and then single switch operation, that is automated welding, flexible welding, there is no operator, welding can be done automatically. Then adaptive welding, the seam tracking, seam corrections, and all these things are coming up. And then remote welding, monitoring and control, these things are coming up. But nowadays, people are thinking for zero defect welds with the mass productions. So there, AI and robots both are used. So let me discuss one by one. As you can see in manual welding, blow pipe, welding gun, electrode holder, these are the prime components. So this is time consuming, one by one you have to do, and continuous welding is not possible. So then coming semi-automatic welding. So this semi-automatic welding, people are thinking of to semi-automate the electrode feeder. As a MIG welding, there are two rollers, they are continuously feeding a wire. So, but a person has to switch on the, like, press a switch through which wire is continuously feeding. So need of highly skilled welder for this semi-automatic welding. So let me tell you one thing, that these images are taken from our recent publication, a critical review on application of artificial intelligence in manufacturing. So all the evolutions and critical review of the application of AI has been taken from there. So okay, so after that, semi-automatic welding is coming, where like people are using numerical control for the welding, for positioning the weld torch and all, and but up to this, your weld quality has been checked by the operator itself, that whether the given parameters are performing good well or not. But after that, flexible welding has come up, where like inclusion of AI has happened. Like AI is what AI is doing basically. As I've told, that sensors and data are must. So here integrated sensors data, as you can see, the sensors has been integrated, like power sensor, voltage sensor, and then vibration sensor, force sensor, torque sensor. This thing, and these things has been this data has been taken and fed it to AI. Then AI will predict maybe the UTS value of a weld to give you a proper picture, that whether the given parameter is giving you a good quality of weld or not. Coming to adaptive welding, so seam tracking is a part of this, like whether it's a track, like in numerical control machine, like you are giving it seam, but whether it is following correctly or not, is there any deviation or not, you have to first detect the seam, you have to make the track. So here machine vision or computer vision is used. Coming to remote welding, now people are thinking to control the welding being out far away from the machine. So they are using cloud computing and IoT based communications. They are using to give feedback to the machine and take the parameter or health data from the machine itself. So these are the things. These are the evolution of the welding. So the present scenario is like robotic welding, AI, all these things are hybridized, and cloud, IoT, all these things are hybridized. Now, what are the like present scenario, that we can do real time monitoring, like during welding we can in situ correction of the data of the process parameter to achieve a good weld. Zero defect well basically is our main goal. So as you can see how AI can help this, and then scrap material will be less, zero labor cost, and AI is also there to take decision. So now still there are many scopes. I am mentioning some of those. As you can see that defects, as Professor Viswas has already told, that quality is a prime concern of the welding, that porosity, lack of fusion, burn through, undercut, and other things, wormhole, blowhole. These things are coming up. These we have to minimize. So for minimizing, we have to nowadays RSO level 2 they are checking the well like this, uh, and they are telling and that okay, in this position defects are there. Maybe in some of the organization they are digitizing it and they are converting it to an image, and in image in a particular software they are checking it. So these kind of things they are doing, but this is time consuming. No, so 10 to 20 minutes they are taking for an checking, and it is time consuming. So AI can do and automate it. And then well sim tracking has been already done, but so we have to see that whether robot can robot can easily more fast it can do it or not. And then collaborative welding, so I have told already that the collaborative robots are not matured enough to be implemented in industry right now. Some of the industries are maybe using, so AI can be more mature in this field. And then virtual reality training with the blessing of our augmented reality and virtual reality, with the integration of AI we can now giving virtual welding training so that welder can feel exactly. So for the training purpose, so much consumables and materials are actually lost in the industries to make the welder skilled. So that we can do now with the augmented reality and virtual reality with the integration of AI. So these are some scopes of AI in welding. So now presenting our works. So this work has been done uh, by Dr. Devasis Mishra from our lab. So uh, so the main concern of this work is real-time monitoring and control of friction stir welding. So, monitoring is a factor that people are doing for last 2 decades, but people are not able to do a proper control of a process because what is the concern basically? The concern is basically the solution should be real-timely deployable. If you are controlling a process, if you cannot instantly pass the data to the machine, then there is no point. So it should be real-time deployable, and then model should be able to not only monitor but also control the process parameter to get an optimum quality of weld. So this is the, as you can see that quality control market size is increasing. So using this method, we are benefit like the benefits perceived are like we can take the faster decision about the quality without any manual intervention. So we can also eliminate the repetition of trial. The machine itself with the AI can predict that what is the best suitable parameter for me, and then UTS value can be predicted in real time. So this is the flow chart of the AI proposed. So multiple sensors that is attached, and then from their real-time signal processing and feature extraction. Basically, wavelet analysis has been done, and from that wavelet, your coefficients has been fed to a ML model. So main here tweaking in the method is like there is two simultaneous ML models are there. One is running in a edge device, that is a local device. If this is giving a decision that is a good quality, if it is not, then the wavelet wavelet coefficients are say fed to a cloud-based ML model, and that will calculate the recommended parameters that is fitting back to the FSW machine again. So this has been patented with TCS. So for a cost factor, return of investment is very high. Downtime, production rate, those are like production rate can be increased and downtime can be decreased. And then scrap experiments for getting the optimal process parameters can be also decreased. So these are the benefits and the things. So as you can see, I am showing you a video that it is a remote welding. A people from a student from IIT Mesra is actually controlling the this FSW, and you see from this image that initially bad parameters were given, so that's why defects are coming up. So gradual improvement of the oil quality has been happened. So now here is the oil quality is very good, whereas the oil quality initially was very bad. So model itself is controlling that in real time. Now coming back to the, sir, am I audible? Hello?
Yes,
Yes,
yes.
you are audible. Yes.
You're
Okay.
audible. Very well.
Okay. Okay. So the next case study is basically to detect the defects, blowhole, porosities, wormhole, and lack of fusion, inclusion from well radiographs. So this has been done for gardeners, shipbuilders, and engineers. I was actively involved in this. So so the defect, the concern is nowadays in GRSE. So there small flaws can be overlooked. LOF can be so faint so that even RSO level 2 they can be they cannot properly, like 100% they cannot do. And then sort of objectivity, intelligence, and consistency. Human interpretation is there. Maybe some person is measuring a defect as 2.3, and some person is measuring the defect as 2.4. So maybe, but from the standards they are telling it as 2.4, 2.5. So some is rejecting, some is accepting. So it is also subjective also. So and also limited time. So whales are in a ship, there are thousands of whales, so they are doing it continuously, and time is less. They have to so AI can help there by detecting it. So this is the solution proposed. But some difficulties I am telling you here, that the images, converted images, whatever has been given to us, that was 16-bit format. That means the values of the pixel are varying from 0 to 2 to the power 16 minus 1, 2 to the power 16 minus 1. So it's a huge range of pixel. So but traditional image processing techniques, they are compatible with 8-bit image. And so we need to convert 16-bit image into 8-bit image in such a way that so much, like those small flaws cannot be it cannot be vanished. So because there is information loss when you are converting 16-bit image to the 8-bit image. And from there what we have studied, that if so the world supervisors or RSO level to their, what they are doing, they are actually we using window, they are actually propagating through the world zone, and they are actually zooming it, they are actually cropping it, and then they are like processing it visually to see the defects. So exactly that thing we are actually copied, or we have using AI we have actually do that thing. So this world zone first we have actually detected, then we cropped it, and then several clips, that windows that we have generated, then it will fed to a pre-trained model, that is a binary classifier. Then it will tell whether that is a defective or non-defective. Then if it is a defective, then we will send it to a multi-level classifier, which will tell that which kind of defects are present. That means classification of defect. And then we will identify the location of the defect in the clip and proportion to the whole image. And then we will cluster. Some porosities are individuals, those are called pores, and some porosities are in cluster, those are cluster porosities. So standards are defined for small pores and big cluster of porosity. So we need to identify like that only, as per the standard. And then we have applied in the measurement that these two protocols, that is NE 773 and ISO. And if it is permissible as per protocol, then it is declared as accepted, otherwise it is rejected. So as you can see, NDT market is very high uh, in India also, it is good. So as you can see, benefits perceived is like very fast detection we can do. And then human like accuracy. So this is the first software on this NDT, so which is actually doing CRS scanner images. So CRS scanners images are using IP plate, this kind of plate they are using. So defects like similar looking artifacts are here and there around the defect. So it is very difficult to interpret from the image that where the defect lies. So that we have done. So it can also only it is giving human like accuracy like RSO level 2, and it is also giving location measurement. And also the thing is, it is giving actually, it is also generating report. Previously they are manually writing the report in Excel sheet, but it is now generating a Excel sheet. So patent is in progress filing with GRS. So this is the software developed by COMT IIT Kharagpur. So let me show you the working of the software. So as you can see, login has to be done, and then here about the GUI you will get the manual of the, and then you have to upload. So some images has been uploaded, and then you have to detect. And here you can see detected image. If you see, this is the defect. It is also telling the length, you see, and then it is generating report. In this report, if you go, then this is the thing they are doing, like on the name of the image and the what are the observations. Now another type of, there are two type of NDT most popular. One is radiography and is another is ultrasonic. So now we are doing the same thing for ultrasonic welding. So in ultrasonic welding, so previously it was image processing, but now the AI is associated with signal processing. So UT, what we are doing basically, we are actually taking each and every rows of the UT data, and we are analyzing them with the AI. So as you can see, these are the detected defects using AI in the UT and UT image and section of an UT image, and then we are measuring the height, width, and the depth of the defect, also giving the location of the defect for us. So this we are doing using AI. So as you can see that defects are detected like this, and it is also validated with LNT. Now the thing is, this is the sample. Every solution we are giving it to industry, we are making a graphical user interface or user friendly software. So this is the thing. So these are some, in this way one can think of to apply AI in welding. So thank you. Any queries?
Thank you, Abhishek. Excellent presentation it was done. And I am sure the participants must have gathered good knowledge out of it.
Thank you, sir.